Our task is to map input speech to 3D gesture animation for conversational agents. We recorded a high-quality dataset of natural unrehearsed speech specifically for this project.
And I remember I was like, right, when he gets off that bike and puts it back up, I'm going to go on it, and I'm going to go down the hill and go down to my granny's. I thought, because I'm big enough, I can do it. If he can do it, I can do it. So I remember I went into my mum. She was in the kitchen. She was like cooking or something, or she was just kind of cleaning up or whatever. And I walked in and I asked her for a cheese sandwich, because she used to make this like gorgeous homemade bread, brown bread. She still does, and it's beautiful. So I asked her, could I have a cheese sandwich? And that I was just telling her that I was going to go on the bike and going to go down the hill.
We train a neural network to generate gesture motion based on input speech. We train a classifier network to detect dynamic structure in gesture motion. This dynamic structure segments motion into phases of acceleration, stillness, and relaxation. Instead of a standard regression loss, we use a generative adversarial training technique with multiple objectives. All objectives are combined into a weighted error function for the generator. Natural gesture behavior consists of phases with qualitatively different dynamic characteristics, and these phases occur in specific patterns. For example, a gesture may start with a preparation phase in which the hands are moved to the starting position. This may be followed by a pre-hold, a moment of zero hand velocity, often to let the speech catch up with the motion. The stroke phase is an accented motion that carries the meaning of the gesture and is the core part of a gesture. After the stroke, the hands may stay in position for a short time. This is a hold. When a gesture is completed, the hands are retracted back into a relaxed position. Labeling phases in gesture data is a tedious process. Just 1 minute of video requires about 1 hour of work. We train a neural network to detect gesture phases automatically from input motion and the speech pitch. With this automatic detection of gesture phases, we can determine the phase structure of any new motion with some confidence. By determining the phase structure of our generated motion, we can enforce more realistic gesture dynamics resembling true gesture behavior. All adversarial training objectives fulfill a distinct role. Standard regression training without adversarial objectives often lead to damped and unrealistic motion. We train a discriminator to detect realistic phase structure. However, to produce a realistic phase structure is not enough of a constraint for the generator. The classifier determining the phase structure of the generator's output may label even unrealistic motion with realistic phase labels, as it has not been trained to handle random point clouds. A second discriminator is assigned the task of determining if the generator's output resembles human motion. However, this type of discriminator can suffer from mode collapse, where the generator learns to produce repetitive patterns. We add mini-batch discrimination to allow motion sequences to be assessed within the context of a whole data batch. Repetitive patterns within a batch will now be penalized. The phase labeling is assessed from the per-frame joint offset, and this is the same motion information as passed to the displacement discriminator. The training objectives regarding phase and displacement are therefore related. When neither of these objectives is included in optimizing the generator, the output motion is jittery with little characteristic gesture dynamics. Adding the displacement discriminator but no phase structure objective makes for less jitter in the output, but the motion still lacks realistic dynamics such as gesture strokes during speech emphasis.
So growing up, my mother always wanted to kind of give us equal opportunities in relation to different art forms and that sort of stuff to take with us into a kind of adulthood. And one of the things that she kind of always made sure that she wanted us to kind of be able to do and take with us was to play music. So initially we started off playing piano.
The displacement discriminator also speeds up the process of moving away from the mean pose early in adversarial training.
So growing up, my mother always wanted to kind of give us equal opportunities in relation to different art forms and that sort of stuff to take with us into a kind of adulthood. And one of the things that she kind of always made sure that she wanted us to kind of be able to do and take with us was to play music. So initially we started off playing piano, which to me now, like looking back, I regret stopping. But first of all, like we did piano when we were in primary school at a very early age. So growing up, my mother always wanted to kind of give us equal opportunities in relation to different art forms and that sort of stuff to take with us into kind of adulthood. And one of the things that she kind of always made sure that she wanted us to kind of be able to do and take with us was to play music. So initially we started off playing piano, which to me now, like looking back, I regret stopping. But first of all, like we did piano when we were in primary school at a very early age.